In South Texas, a gleaming tower of stainless steel stands ready to launch, Starship Flight 10. This moment is the culmination of years of relentless innovation, risk-taking, and the pursuit of a dream that once seemed impossible. The anticipation in the air is electric, as engineers, space enthusiasts, and dreamers around the world turn their eyes to Starbase, waiting for history to unfold. This isn't just another rocket launch, it's a turning point in our quest to reach the stars. Each ignition, each countdown, brings us closer to a future where space is within reach for more than just a select few. The stakes are higher than ever, and the world is watching to see if humanity can take this next giant leap. Starship aims to make space travel as routine and affordable as air travel, unlocking new possibilities for science, exploration, and humanity. Imagine a world where researchers can launch experiments to orbit with ease, where astronauts can travel to the moon, Mars, and beyond, and where ordinary people might one day look up and see a path to the stars. SpaceX is pushing boundaries, attempting maneuvers never before tried at this scale. Every bolt, every weld, and every line of code is part of a bold experiment to redefine what's possible in aerospace engineering. A successful mission would prove the concept of a fully reusable launch system, supporting next-gen Starlink satellites, NASA's Artemis program, and the dream of Mars colonization. It would mean more frequent, affordable launches, and open the door to missions that were once the stuff of science fiction. This flight is a test of engineering and a bold new philosophy for space exploration. It's about learning fast, failing forward, and daring to try what others have only imagined. It builds on lessons from 9 previous flights, each one shaping the design and approach. Every setback has been a stepping stone, every success a validation of the vision. SpaceX's engineers have worked relentlessly to address past failures, making Flight 10 a testament to resilience and rapid iteration. Their dedication and creativity have turned obstacles into opportunities and setbacks into sources of inspiration. The world watches, not just for the spectacle but for what it means for our future as a spacefaring species. For many, this launch represents hope, curiosity, and the unyielding human spirit to explore the unknown. Whether it ends in triumph or another lesson, Flight 10 is a crucial chapter in humanity's journey beyond Earth. Each attempt brings us closer to a day when space travel is part of everyday life, not just a distant dream. The story of our expansion into the cosmos is just beginning, and Starship Flight 10 is helping to write the first pages of that incredible adventure. To truly grasp the significance of Flight 10, we first need to understand what makes Starship so revolutionary in the world of rocketry. Starship isn't just another rocket, it's a bold leap forward, designed from the ground up to change how humanity explores space. Standing over 120 meters tall, Starship is a 2-stage, super heavy lift rocket, the largest and most powerful ever constructed, dwarfing even the legendary Saturn V and Space Shuttle. It's engineered to carry more than 100 tons of cargo, and eventually, dozens of people, into orbit, paving the way for ambitious missions to the Moon, Mars, and beyond. But the real game-changer is Starship's full and rapid reusability, a feature that sets it apart from almost every rocket before it. Unlike traditional expendable rockets, both the Super Heavy booster and the Starship upper stage are designed to return to Earth, land vertically, and be ready to fly again within days, dramatically increasing launch frequency. This approach could slash launch costs, making space more accessible than ever before, and opening the door to a future where space travel is routine. Starship's body is crafted from stainless steel, a material chosen for its strength, affordability, and unique ability to withstand both the freezing cold of space and the intense heat of re-entry. Powering this giant are the Raptor engines, a new generation of rocket engines that are not only efficient and powerful, but also designed for repeated use. The Super Heavy booster alone is equipped with 33 Raptor engines, generating more than twice the thrust of the mighty Saturn V, making it the most powerful rocket stage ever built. Starship isn't just an upgrade to existing technology, it's a complete reimagining of how we reach and utilize space, built for a new era of exploration. By combining immense power, robust and innovative materials, and true reusability, Starship aims to make the final frontier truly accessible for science, industry, and even ordinary people. Missions like Flight 10 are where this bold vision is put to the test, pushing the boundaries of what's possible and bringing us closer to a multi-planetary future. Starship Flight 10's mission is a carefully choreographed series of high-stakes tests, each one pushing the boundaries of what's possible in modern rocketry. Every step is designed to validate new technologies and operational techniques that could redefine the future of space travel. It all begins with the thunderous ignition of 33 Raptor engines, a breathtaking display of raw power that lifts the massive rocket skyward, shaking the ground and lighting up the horizon. The hot staging separation, where the upper stage ignites while still attached, maximizes performance and payload, representing a bold engineering solution to increase efficiency and reduce turnaround time between flights. After separation, the Super Heavy booster embarks on a complex, controlled descent, using grid fins to steer itself back toward the launch site. Its ambitious goal? To be caught mid-air by Mechazilla, the giant robotic arms on the launch tower, a maneuver never before attempted at this scale. Perfecting this catch is key to rapid reusability, allowing rockets to be quickly refurbished and flown again, dramatically lowering the cost of access to space. Meanwhile, the upper stage continues its journey, pushing toward near-orbital velocity. It faces its own set of critical tests, including high-speed maneuvers and engine burns in the thin upper atmosphere. A major milestone is the successful relighting of a Raptor engine in space, an essential capability for future deep space missions, lunar landings, and interplanetary travel, where reliability is paramount. The ship will also open its payload bay and deploy mock Starlink satellites, demonstrating its ability to carry and release large payloads, and proving its utility for massive satellite constellations and cargo missions. Finally, Starship will re-enter Earth's atmosphere, relying on its advanced heat shield and aerodynamic flaps to survive the fiery descent. The mission culminates in an attempt at a controlled splashdown, testing recovery systems for future flights. Each phase is a leap toward proving Starship's design for safe, reliable, and fully reusable spaceflight, bringing humanity closer to routine missions beyond Earth. Success here paves the way for the next era of exploration, opening the door to the Moon, Mars, and destinations yet to be imagined. Starship Flight 10 stands on the shoulders of prototypes that often ended in spectacular failure. SpaceX's fail fast, learn faster philosophy means every explosion and mishap is a lesson, not a setback. Early landing failures led to redesigned fuel tanks, improved control software, and more reliable engine relights. Booster mishaps revealed weaknesses in both the rocket and the launch pad, prompting major upgrades like the water-cooled steel plate and deluge system. Each failure, from tank ruptures to attitude control losses, drove specific improvements in structure and systems. Even ground test explosions led to safer pressurization systems and stronger airframes. This relentless cycle of building, testing, and improving is what sets Starship apart. Flight 10 is the sum of all these hard-won lessons. Flight 10 isn't just a repeat, it's a showcase of new technology and upgrades. The thermal protection system features improved ceramic tiles and stronger attachments to withstand re-entry heat. Raptor engines have been upgraded for reliability, especially during relight sequences. Avionics are smarter and more redundant, with enhanced sensors for real-time health monitoring. The vehicle's structure is reinforced, drawing on data from past failures. Ship 37, the upper stage, debuts a lighter, safer pressurization system. Even ground systems have evolved, with new static fire methods and portable deluge systems. All these innovations make Flight 10 the most advanced Starship yet. Preparing Starship for flight is a feat of engineering and coordination. Ship 37 and Booster 16 began with assembly and rigorous ground tests, including cryogenic proofing. Static fire tests verified engine and system readiness. Each system is checked in isolation, then integrated for full vehicle rehearsals. The final step, stacking the stages and conducting a wet dress rehearsal, simulating the entire countdown. Beyond technical checks, FAA clearance is essential, ensuring all safety and regulatory requirements are met. Only when the rocket, weather, and paperwork align does the countdown proceed. Every detail must be perfect for launch day. The true impact of Flight 10 is what it unlocks for the future. Success would mark Starship's transition from prototype to operational system, enabling the launch of next-gen Starlink satellites. Starship is central to NASA's Artemis program, with a modified version set to land astronauts on the Moon. Before carrying crew, Starship must prove itself through uncrewed missions. Flight 10 is a vital step. Ultimately, Starship's goal is Mars, carrying the cargo and people needed to build a city on the Red Planet. Each test flight brings that vision closer. Flight 10 is a rehearsal for humanity's next great leap. Its legacy will be measured in inspiration as much as technical achievement. It challenges us to dream bigger, to innovate, and to reach for the stars. The journey is just beginning.